In this section, you will be working with some word problems for the Algebra 1 material that we've been doing in class. I wanted to cover from section 1.7 the even numbers from 2 to 8. That was the assignment from Tuesday. Number 2, the gym is 21 years newer than the auditorium. The gym is also 1/4 as old as the auditorium. How old is each building? When you start doing this, what we've been covering in class is that you want to set up the problem first. So I'm going to put A for auditorium and G for gym, and I want to see how those relate to one another. The first statement is the gym is 21 years newer than the auditorium. So I'm going to use that to set my relationship. If the gym is 21 years newer, then what I want to put is that the gym is X because that's the smallest age. The auditorium is 21 years older than the gym, so we're going to say X plus 21 for the auditorium. Now the second statement, the gym is also 1/4 as old as the auditorium. Now on this first part, I said the gym is 21 years newer, and then I turned that around and I used reverse logic on that to say the auditorium is 21 years older. I'm going to do the same thing with this 1/4. If the gym is 1/4 of the auditorium, then the auditorium is 4 times the age of the gym. Now, if you have trouble with reversing that, you'll get better at that as you go. But if you have trouble with that, basically what I just did there, put a hypothetical number in. If the gym is 1/4 as old as the auditorium, then if the gym is 10 years old, which it's not, but we'll just say it is, then the auditorium, if the gym is 1/4 of it, would be 40 years old. So you have a multiple of 4 going on. So in one aspect, going from gym to auditorium's age, it's 1/4. When you turn it around, you'll use a reciprocal of 1/4, which is a multiple of 4. Now combining those two things, I'm going to look specifically right here. Auditorium is 4 times the gym's age. So instead of A, I'm going to use my expression X plus 21. Is will be equals, and then 4 times G is 4X. Now if you would rather use the gym is 1/4, you can do that too. It's just a little more confusing usually. But the gym, be X, is 1/4 of A. I'm getting that right here. And we set A as X plus 21. Now an easier way to write that is X equals X plus 21 over 4. So we'll run through this. If I multiply by 4 on both sides, that'll clear my denominator. So I end up with 4x equals x plus 21, which is the same equation as I had over here. Now to solve this, I do minus 1x on both sides. So on the left side, I'm left with 21. On the right side, I have 3x. Divide by 3 to solve for x. I'm going to turn that around, make that x equals 7. Go back up here into your original problem setup, and you'll say x is 7 years old. And then if you add 21 years to that, that'll give you the age of the auditorium, which is 28 years. So 28 years old and 7 years old will satisfy both statements. The gym is 21 years newer, and the gym is 1/4 of the age of the auditorium. So this box contains the answers to the question, how old is each building? Now moving on to the next one, number 4. I have a number that is 4 times another number, and the larger number is also 87 more than the smaller number. So I'm working with the larger number and smaller number. So let's just say large and small. And I'm going to use this first statement to set up how the two numbers relate to one another. One number is 4 times another number. Well, the information in the book, they give you 3 possible numbers that it could be. They're all positive. So we're just going to make the assumption on this one that it's going to be positive. If one is 4 times another, I'm going to set my small one as x because if I do 4x up here, that number would have to be larger. It's a positive number, so it must be larger. So that satisfies this first statement right here between my bars. So now I'm going to utilize my large and small settings here to take care of the larger number being 87 more than the smaller number. So the large number is equals 87 more than the smaller one. In place of large, I'm going to put my 4x right here. So 4x equals 87 plus, and instead of small, I'm going to put x from where I started setting my problem up right here. Let me get rid of this. So let's solve this out. I'm going to take 1x from both sides, so I get 3x equals 87. Divide both sides of your equation by 3, so I get x equal to 29. And I'll go over and insert that into my problem setup. The first number is 29. Now to get my second number, I have to multiply 29 by 4. So I get 4x is 116. If I want to check my work to make sure I satisfy both of these statements, I want to make sure that 116 minus 29 truly gives me 87, like the problem says it should. So just a quick check on that. The difference is 87. So this box contains my answers again. So what's important is that you have a way of setting up the problem that'll help you decode the information you're getting. And then be sure to go back and answer both sections of that problem. So let's look at two more. Number 6. A clown weighs 60 pounds more than a trapeze artist. The trapeze artist weighs 2/3 as much as the clown. How much does each of them weigh? So we'll do C and T for clown and trapeze artist. I'm just going to use the first statement to set my relationship up as I did in the last two. If the clown weighs 60 pounds more than a trapeze artist, I'm going to set the trapeze artist as X, the weight of the trapeze artist. The clown weighs 60 pounds more, which will be X plus 60. Now once you get that process down, now you're ready to start on the second statement. The trapeze artist weighs 2/3 as much as the clown. Use that to set your equation. And it sometimes helps. The trapeze artist weighs, or is, equals 2/3 of the clown. So in place of trapeze artist, I'm going to put the X that we set right over here equals 2/3 times X plus 60. Another way of showing that would be X equals 2X plus 60 over 3. That's still 2/3 X plus 60, and it might help you see how to solve it easier if the fraction looks unfamiliar to you. The way that you solve this equation, the first step would be to multiply both sides by 3. So if I do 3 on both sides, what happens is I cancel this 3 out, so I just eliminated my fraction. At the same time, I want to distribute the 2 to the X and the 60. So I get 3X equals 2X plus 120. By subtracting 2X from both sides, I'm left with 3x minus 2x is just x, is 120. So now I'm ready to plug these numbers in my original setup. So x is 120 pounds. If I add 60 to that, I get 180 pounds. And that should be the solution. Now I can check this 2/3 right here. If I take 2/3 of 180, I'm going to cancel the 3 with the 18, leaving me with 60, and 2 times 60 is 120. So that verifies my answer. All right, and the last example, the 9th grade class has 17 more girls than boys, with 431 students total. How many of each are there? So we'll do B for boys, we'll do G for girls. So there's 17 more boys, or excuse me, 17 more girls than boys. In other words, there are fewer boys. I'm going to set that as my X. That's the number of boys. So there's 17 more of girls, so x plus 17 is the number of girls. So that is this first statement taken care of. Now I want to use 431 students in all to add together boys and girls. So the number of boys and the number of girls should be 431. In place of boys, put the x. In place of girls, put x plus 17 and make that equal to 431. I'm going to combine my x's. X plus x is 2x. Go ahead and subtract 17 off. Now the parentheses here are simply denoting this expression. They're not creating an order of operations problem due to a commutative property. I can regroup x plus x and leave 17 outside of parentheses. So I'll go ahead and move 17 over. So 2x equals, and if I do 431 minus 17, I'm going to get 414, I believe. Divide both sides by 2, and x will be half of 400 is 200, half of 14 is 7, so x is 207. Go back over here. Number of boys then will be the x value that we just solved for, 207 boys. Add 17 to that, I'm going to get 224 girls. And the way to check that is just to be sure that we get 431 total students. 207 plus 224. 7 plus 4 is 11. Make that a 3, 4, and it checks out. All right, so there's some examples. The main thing on doing these word problems is to be sure you understand how to set the problem up first. That's the first step. Just use your opening statement to do that. If you need to reverse the logic, then try to familiarize yourself with what that means. Make sure that you use the second statement to write an equation. It might help to use some abbreviated shorthand here, like the b plus g equals 431, to help you figure out how to write that equation. And in the end, since you can correct your work, you can check your work with the information you're given. Just be sure you're right, like we did here, checking for 431. All right, in the actual assignment, I think you're going through 18, but they're all the same basic way of solving them, but you'll have a couple curveballs in there. So good luck, and we'll cover your questions in class.